Hello everyone, in this video we're going to learn one of the super cool way to traverse a tree, which is called as level order traversal, and it can also be called as a breadth first search as well. And what's special about this particular video is there is a lot of videos out there and everything is super good, but one special thing about this video is that we are going to explain the reason behind using the queue for level order traversal. Actually, this is a spoiler, but that's fine. So I just have to tell the reason for watching this video. Yeah. Now, without wasting much time, let's get started. As a first step, let's learn about what is a level order traversal. I think by looking at this picture, you can see how level order traversal looks. I just made a really good picture, which will showcase how the level order will go. So if you take a traditional BFS solution, we go to the deep end and then left, right, like that will go. But in level order traversal, we have to go level by level like this. We will visit all the node in a particular level. Then we are going to visit the next particular set of node in a level 2. Then once we finish this level 2, we are going to move to level 3. So you can see the direction I'm just putting from left to right. So in level order traversal, we have to visit the node from left to right direction. So level order traversal is nothing but visiting all the node in a particular level before proceeding to the next one. Okay, just note this point. You have to visit all the node before moving to the next particular level. That's why I did it. When you're coming to this particular level, you have to visit all the node. Now once I visit this node, then I'm going moving to the second level. On second level, when I visited this 2 node, I'm going moving to the third level. Okay, now I'm going to start visiting from the left till the end. Once I've done all the things, I'm moving next particular node. This is the definition for level order traversal. I hope you guys understand what is mean by level order traversal, how does it works. Now it's time for us to learn about the algorithm behind it and reason behind using the queue data structure, all those things. Now let me take this particular tree as example. If you remember how that flow will go, I mean how the traversal will happen is, we'll start from this particular node. Let's take the root node. We'll start from the root node. Once we visit this, we are going to print it over here. Okay, let me write it down. And then once we completed the level, particular level, this level has been done. Next step, what is the next step? We have to move to the next particular level. I'm moving to the next particular level. As I said, we are going to visit from left to right. Okay, so now we came to the level 1 and we are visiting the node 2. Let me put it over there. And then once we visit it, we are going to move to the next particular node. Yeah. Now I came, we just visited it. What is the next step? We have to move to the next level. We are going to visit 4 and then 5 and then 6 and then 7. So 4, 5, 6, 7. What is the next step? Once all the nodes is visited in a particular level, we have to move to the next one. That's right. It's going to be 8 and then 9. So this is how the BFS travel will look like for this particular tree. Now the question comes, how do we do this traversal algorithmically? How do we code this up? That's like super duper question. Let's start with a single pointer. Okay, let's start by a single pointer. Let me put a current pointer over here. So current pointer, which is on the root node. Now I will just mark as we visited. Now what is the next step? We have to move to the left node, right? Let's move to the left node. Now we visited the left node. So let me mark as visited as well. Now I need to visit 3. But how can I go to the 3? How can I go, guys? How can I go to this particular place? Do you have any kind of connection? No, it doesn't. One way is that I have to go back and I can come this particular place. But on a tree, when you come down, there's no way of going back. Am I right? If you come down, there is no way you can go back. So eventually you cannot reach to this particular tree with a single pointer. So you cannot reach, right? You just move the pointer to this particular node and you just need to move to this particular position, but you cannot move. Am I right? But you can move to this particular place because there is a connection over there, but there is no connection between 2 and 3. That is one connection, which is I have to go back and I have to come to the 3. But that's not possible in our case because in a tree, you cannot move upside. You can only move to the child, but you cannot move to the upside. So we can clearly tell that single pointer is not possible. So that's where queues comes into the place. So it's going to solve the problem of referring. So what basically we are going to do is that we are going to have a queue, and queue is going to have the node which is been discovered but it's not yet visited. Note this point, which is being discovered and not yet visited. So we're going to have the reference of all the children for the particular node. Okay, we are going to put everything in a queue, and then we are going to pop everything in a sequential manner. And this is also a very important point. Whenever you're just dealing with a sequential based question, always queues comes into place. If you look at this particular sequence, how does it look, guys? It is in a sequential manner. Okay, it is in a sequential manner. So whenever you dealing with a sequential based problem, just think about a queue, whether you can use queue or not. In this particular problem, we are going to use the queue, and we are going to utilize the property of queue, which is first come first served. Whatever is coming inside, it will be served first, and then only next particular set of items. So now let's get into the algorithm. Now let's apply the algorithm, guys, whatever we discussed right now. First of all, always the root node will be in a discovered queue. Okay, so we'll put a 1 over there, and remember, discovered node means the node that has been discovered but yet to visited. So it's not visited, it just discovered. Now as a first step, we'll put a root node in a queue, and we are just going to pop it. So once we pop it, what we are going to do is that we're going to take all of its children and put it in the queue back. Okay, so what is this children? Children is going to be 2 as well as 3, right? Now we just got a reference for all of its children. What's the next step, guys? And one more thing, guys, whenever you just pop the element, you have to make an array, you have to push it over there. The reason, because in lead code question they ask you to return list of list, which means if you look at this particular element, you are seeing and list contain ones, which means on a level 0 what are the element present. And if you look at this particular thing, it tells what are the element present in level 1, and this tells what are the element present in level 2. So whenever you just pop, push into an array, and then at last you are going to push that new array to the result. So just keep this in mind. So I just pop 1, I'm just going to put in an array and push it to the result. So 1 is done. Now next step, what is the next step? So next step is to visit all the node in the queue. So we have discovered 2 particular node, and we have to visit this 2 node and get all of the children and push it to the queue. You guys get it? So now we are going to take node 2, and we just took a 2. Okay, remember to make a list. I'm just going to put a 2 in a list, and I'm going to take its child and push it to the discovered node. What is its child? It's going to be 4, it's going to be 5. Am I right? Right now this both thing has been visited. Now what is the next step? I have to take the remaining discovered element in a level 1, which is 3. I'm going to take a 3 and push it into an array, and then I'm going to visit its node and push it to the discovered queue. What is its node? Which is going to be 6, 7. Am I right? Now we just finished at the level 1. So just push this list into this particular array. It's going to be 2, 3. I hope you guys understand it. Now what is the next step, guys? We just visited level 0, level 1. Our next step is that we are going to visit all the element in a level 2. Let's do that. Let me create a new array, new empty array, and I'm going to start visiting the nodes. So I'm going to visit 4. Let me put 4 into the array, and I'm going to check whether 4 have any child or not. Yeah, it does. So I'm going to put 8 and 9 into the queue. And now what is the next step? I have to visit the next element, which is 5. Let me put 5 over there, and I'm going to check whether any child is there for 5. Nope, it doesn't. Fine. And I'm going to do for 6. Is there any child? Nope, it doesn't. Same for 7. So put 6, put 7, and that's it, finished. Is there any element pending in a level, this particular level? Nope, it doesn't. So simply push this into the result. The next step, what is the next step? It's going to be visiting the last level. Let's take node 8. I'm going to take 8. I'm going to check whether 8 have any children or not. Nope, 8 doesn't have any children. That's it, finish. And then I'm going to take 9. So 9 have any kind of children? No, it doesn't. So that's it. We are going to push this array also to the list 8, 9. So that's it, guys. I hope you guys understand this particular problem very easily. Now let's quickly code this up, guys. So as we discussed the algorithm, we're going to have the Q result. So let me declare that. So Q is going to be, which is going to have the root node as well as the result. Now we just did our first step. The next step is going to be that we are going to loop the queue until it get empty. So while length of queue is not equal to 0. So till that we are going to iterate it, and then we are going to do the operation. So next step, what is the next step? We have to declare the current level. Am I right? So what we are going to do now is that we are going to take all the node in a particular level, push to this current array, and this is going to be pushed to this result. So that's how lead code wants us to return. We can see the output format. So now let's continue the process. What's the next step? We're going to take all the nodes from the current queue for I in range length of a queue. So let's pop the node. So node is going to be queue dot pop left. What's the next step, guys? Tell me. So we're going to check for its children. If children is there, we are going to push it to the queue. So if node dot left, and then we are going to push append node dot left. Same for the right child. If there is exist of a right child, we are going to push back to the queue. And then at last, what we are going to do? We are going to push the current node value to the current list. So current dot append node dot val. So once all these things done, we are going to have all the element in a particular level to this array. So this array is going to contain all the element in a level. So we are going to push this array to the result. So result dot append current. So at last we can simply return the result. And now if I want to talk about the time complexity, it's going to be big O of n. And then space complexity is also going to be big O of n, because we are just visiting all the node only one particular time. Now let me run this code. Oh, we just forgot the base case, guys. So what if there is no root? If there is no root, we are not going to have any element. So if there is no root, then simply return an array. So this is the reason why it caused this particular issue. Now let's run this. Yeah, it passes successfully. Now let's submit this and see. I hope it passed for all the test cases. Yeah, it does. And thanks for watching till this, guys. We'll see you again one more video. Until then.